All right, we have a video here that's going to show you how to graph logarithmic functions. There's some things you need to memorize when you graph logarithmic functions. It will help you out as far as just identifying if you've graphed it correctly. If we're looking at the function here, log base b of x minus h, and then you're going to add k there at the very end. Well, what happens? Well, x equals h is the vertical asymptote. Now watch this. I will show you an example. Remember, this is supposed to be x minus h. And in this example, this says x plus -2 because that says x minus -2. And when we're trying to identify the vertical asymptote, it is supposed to be x minus h. So therefore, h is -2. The vertical asymptote is going to be the line x equals -2. And how do you graph that x equals -2? It's a vertical line like that. And so there's your vertical asymptote. We know that the domain of this is going to go from here all the way out. And that's the domain. We're talking about the x values. And the range will go, it'll actually go from -infinity all the way up to a positive infinity. And so that's just the range. Now the two black marks I put on there was not the graph of that logarithmic function. It was just talking about domain and range, which is what we talk about when we get back to here. The domain will be greater than h, and the range will be all of the real numbers because it goes from -infinity to positive infinity. Okay, if your base b is greater than 1, let's say if we had a vertical asymptote like this, greater than 1 for b, it is going to move up and to the right to look like something like that. And if b is between 0 and 1, it's going to move down and to the right. Something similar to like that. So it's why it's helpful to understand what's happening here. Vertical asymptotes have nothing to do with whether it moves up and to the right or down and to the right. I know these vertical asymptotes were in different locations, but it's b that makes the difference. Basically, if you're going to graph these without technology, you have to make a table. You can toss this into the graphing calculator, see a graph real quick, look at a table of values, but you're going to need to know how to do this without a calculator. And so let's go ahead and show you how to do that. You know that if you have it y equals log base 5 of x, that you need to get some points here. So let's change this to exponential form, where it's going to be 5 to the y power is equal to x. And let's come up with the table of values, x and y. Now you want to be real selective, real thoughtful in what values you want to pick, because like say if we want to pick 1 for x, which we're not going to, but if you want to pick 1 for x, 5 to what power is equal to 1? That one is actually pretty easy. 5 to the 0 power is equal to 1. What about if we pick 2? 5 to what power is equal to 2? And then that one gets a little more difficult. So actually, it might be better just to plug values in for y. 1, 2, 3. How about those values? So 5 to the first power is equal to 5. 5 to the second power is equal to 25. 5 to the third power, 125. 5 to the fourth power, 5 to the fourth power is 125 times 5, which is going to be 625. Okay, so we have those values. What about if we did some negative values? Negative 2, negative 1. 5 to the negative second power is equal to 1 over 5 squared, and 5 squared is 25. How about 5 to the negative first power? 5 to the negative first power is 1 over 5. Okie dokie. So we plugged in for y, and we were able to find x. Now let's graph our points. Well, the vertical asymptote here is, remember, plus 0. So the vertical asymptote is just the y-axis there. Wow, we need to go to 625. 625. So maybe we go up by 50s. So this would be 100, 200, 300, 400, 500. Still not going to get us there. It'll get us close enough. All right, so let's go ahead and graph. Let's go ahead and graph. And you know what? I was looking to get to 600 on the y-axis, and we don't need 600 on the y-axis. We need 600 on the x-axis. We only need to go to 4 on the y-axis. So 100, 200, 300, 400, 500, and I'm going to put 600 there. All right, so let's graph. 1, 0, 1, 0. Well, if this is 50, 1 is somewhere right here. 5, 1, somewhere there. 25, 2. 25 is like halfway, and 2 would be not much further. 125 and 3. Well, here's 100, 125 and 3. I'm completely messing this up. Let's let this be 100, this be 200, 300, and so forth. This is 1, 2, 3, 4, 5. There we go. Let's do that. That's going to make the graph actually look like it's supposed to be. 1, 0. 5, 1. So that would be something like that. 25 and 2. 25 is halfway. Maybe my 5 is actually too far to the right, but we'll get the point of it here. 125. 125 is here and up to 3. 625 and 4. 625 is way out here, and 4, something like that. And do you think we're going to be able to graph 1/25 and -2, 1/5 and -1? Those are going to be super close to the line. So your line, and I called it a line, it's not a line. Your function should look like that. Okie dokie. You're going to have to make some tables, use some, make sure you're using equal intervals, 100, 200, 300, and 400. Make sure you use equal intervals when you do these graphs. And actually make sure you graph them right, unlike I was doing at the very beginning. Hopefully that was a good learning opportunity for you. Okie dokie, so looking here, if you have y equals log base 10 of x, a lot of times you will see this written as log of x. When you don't see the base written in there, you know that's going to be a base 10. That's the only base that we do that with. We know that it's going to be base 10 when it's invisible. Kind of like in front of, like an x in front of, like if you're solving an equation, that's an invisible 1. If you have 5, you know there's an invisible 1 for the exponent. Well, when you're talking about bases in logarithmic functions, if you have a 10 there, that is also an invisible 10. So you can see it both ways. All right, I'd like to see you try to graph this one on your own. I will make a quick table for you after you hit play, and you can match my values with your values and see if they match up. I know that this is going to be 10 to the y is equal x. I want my table to go -2, -1, 0, 1, 2, 3. That's going to be the y. We can calculate the x. So 10 to the -2nd power is 1 over 100. 10 to the -1st power is 1/10. 10 to the 0 power is 1. 10 to the 1st power is 10. 10 to the 2nd power is 100. And 10 to the 3rd power is 1,000. I'm sure you can get creative in making your graph. And I'm not going to graph that one. I feel like you can graph points. Okay, we're back to the example we hit up earlier. We found the vertical asymptote to be x equals -2. We've kind of plotted it on there. And so that's what we have there. That is not what I wanted to do. So let me get all this together. And I will slide this over here a little bit out of the way. Because we know the domain is going to be to the right of that vertical asymptote, that's going to be all the values that are greater than -2. That's the domain, and the range, of course, is all real numbers. So let me go ahead and get rid of this, and let me get rid of this. And let's come up with a table of values. Well, let's change it to exponential form. We know 3 to the y power is equal to x plus 2. But typically, we want x to be a function of y, so we want to get x by itself. So that means 3 to the y power minus 2 is equal to x. We just subtracted 2 from both sides. And I think we can easily find a table of values now. So making our table, I have no clue what I was putting a negative sign there for, but I do know that I want a y there, and maybe that's because I was going -2, -1, 0, 1, 2, and 3. So then the x values would be what? Well, let's go ahead and plug those in. 3 to the -2nd power minus 2. 3 to the -2nd power, 3 to the 2nd power is 9, so 1/9 minus 2, well, we need common denominators, so that's going to be 18 over 9. 1/9 minus 18 over 9 is going to give us -17 over 9. 3 to the -1st power minus 2, that's just going to be 1/3 minus common denominators, 6/3. Okay, 3 to the 0 power minus 2, 3 to the 0 is 1. 1 minus 2 is now -1. 3 to the 1st power, which is 3, minus 2, which is 1. 3 squared, which is 9, minus 2, that's 7. And 3 cubed, which is 27, minus 2, 25. Okie dokie then. We know that our highest x value is 25, so if we were to go by If we were to go by, like, say, threes, 3, 6, 9, 12, 15, 18, 21, 24, 26. There we go. We would get 25 in there. Y values are going to be, yeah, we can go up by ones with the Y values. 1, 2, 3, 4. There we go. All right, let's graph 25 and 3. 1, 2, 3. It's somewhere about here. Let's graph 7. Let's see, this is 6, so this is 7. 7 and 2 is somewhere about right there. Let me go ahead and put these on there. Not that one, okay. And now we need 1 and 1, somewhere right there. We need -1 and 0. Oh, it's hard to see, black and black. Same color on the same color, it's a little challenging to see there, but you'll manage. And -5/3, which is -1 and 2/3, which is somewhere close to -2. So -2 and -1. And then we have -17/9. Why is it not matching up here? Because I thought a vertical asymptote was -2, x equals -2, but -17/9 is close to -2 right here, -17/9. Well, see, the thing is, we put the vertical asymptote on there when the x values were going up by 1 and down by 1. So the vertical asymptote has changed when we changed our x scale to be going up by 3s. And so there's the vertical asymptote, our line, or our function, something like this. There we go. Now we have the vertical asymptote at x equals -2 with our change scale, and then we were able to graph some points on to our graph there. Okie dokie, let's move on. Y equals log 1/2 x minus 1/2. We know that it's going to go down into the right because it's between 0 and 1. All the other ones we've dealt with have gone up into the right. And x equals 4 is going to be the vertical asymptote. Before I go ahead and put the vertical asymptote on there, I don't want to cause any confusion like I did in the last example. So we're not going to put it on there at the moment. We're going to wait and determine what our scale is before we do that. But we know it's going to be on the positive side, so we'll go ahead and slide our graph out of the way. Okay, let's turn this to exponential. Exponential, so we know y, 1/2 raised to the y, is equal to x minus 4. And so 1/2 raised to the y. We want to get x by itself over there, so let's add 4 to both sides. And that's what x is equal to. Let's go ahead and make a table of values. Here's x, here's y. And let's let y equal 2, 1, 0, -1, -2, -3. And so you notice here that I have more negative values for y than positive values. It's because you're going to have the reciprocal. When you work with negative values, you're going to have the reciprocal, which would turn 1/2 into, 2/1. And let's go ahead and show you what I was talking about. Let's go 1/2 to the -3rd power plus 4. Well, we know the negative exponent means a reciprocal, so that's going to be 2/1, and then it becomes a positive exponent plus 4. So 2 to the third power is 2 times 2 is 4 times 2 is 8, so this is 8 plus 4, which is 12. So now, instead of negative 3, let's have a negative 2 there. When we do the reciprocal, it becomes a positive 2, and 2 squared is 4. 4 plus 4 then is 8. And negative 1 there becomes a positive 1. 2 plus 4 then is 6. Plug 0 in there. 1/2 to the 0 power. 1/2 to the 0 power is 1 plus 4, which is 5. All right, now we're getting down to the positive values. 1/2 to the first power is 1/2 plus 4. That's going to be 4.5. And then let's go to the second power. So we know 1/2 squared, that's 1/4. And so 1/4 plus 1/4, or I'm sorry, 1/4 plus 4, 4 and 1/4. And you notice how it's getting closer to 4? I mean, we could go to the third power. Go to the third power. And this now is 1/8 plus 1/4, which then is 4 and 1/8. And it's just getting closer and closer to 4, which kind of makes sense since our vertical asymptote is x equals 4. All right, so if we need to get to 12 on the x-axis, I say we just go continue by ones. And we make, if this is 10, this is going to be 11, this will be 12. And yes, those are pretty close. Okie dokie, let's plot some points. 5, 0, 1, 2, 3, 4, 5, 5, 0, 6, negative 1, 8, there's 7, 8, negative 2, and 12, negative 3. We're going to have 4.5, 1. We're going to have 4 and 1/4 be 2, 4 and 1/8 be 3. And if our vertical asymptote x equals 4 looks like that, our graph should look somewhere close to that. Okie dokie, I have two more. This example I'll help you through, and the next example you can work through yourself. So vertical asymptote we know is going to be 0. Remember, x plus 0. So the vertical asymptote will be x equals 0. So we know that that's the y-axis. You can go ahead and put that on there if you want. You don't really have to even put it on there to begin with, but it's just helpful for you. We know that the base is positive 4, which is greater than 1, so it's going to open up and to the right. And so now we just need to turn to exponential form. So we have 4 raised to the y power, and that's equal to, I'm not going to use plus 0 here, that's equal to, whoa, this one's a little different, because that plus 3 isn't inside the parentheses there, is it? Well, you do know that from your days of solving an equation, you'll want to get rid of this positive 3 first. So how do we get rid of that? We subtract it. Y minus 3 is equal to log base 4 of x. And when you do that, now we can go ahead and say 4, the base, raised to this power, y minus 3, and that's going to be equal to x. There you go. Now, how do we solve this out? Same way. Make a table of values. Here's x, here's y. And let's go ahead and go from there. Let's pick some values. We'll pick -2, -1, 0, 1, 2. And we'll even go 3. We might even go to -3 here in a second. And just plug them in. Let's start with -2. 4. What is -2 minus 3? That would be -5. And that would be equal to x. Well, we know that's going to be 1 over 4 to the 5th power. And what is 4 to the 5th power? Well, we know 4 squared times 4 squared times 4. So this is 16 times 16 times 4. 16 times 16 is 256. And 256 times 4, well, that is 250 times 4 and 6 times 4. 250 times 4 is 1,000, and 6 times 4 is 24. So 4 to the 5th power is 1,024. 1 over 1,024. Probably not going to be very much fun to graph that one. You can graph it, though. I'm sure you can find some small dot to put there on that point. Well, I know that since I'm subtracting 3 in the exponent there, I should probably start with values that are a little closer to 3. Let's do 2. Let's figure out what happens when we put 2 there. That is 1. That'll be 2 minus 3, which is equal to 4 to the negative 1st power, which is equal to 1 over 4. And that's getting more manageable to graph. So let's pick 3. That would be 3 minus 3, which is 0, and we know 4 to the 0 power is 1. All right. So let's get some larger values here, 4 and 5. So 4 minus 3 is 1. 4 to the 1st power is 4. Now 5. 5 minus 3 is 2. 4 squared is 16. And let's go one more just for the kicks. 6 minus 3 is 3, and 4 cubed. 64. So we have like 5 points there. We could probably graph those. And granted, we have to get to 64. Well, I'm going to go by 5s. That would be 10. This would be 50. And I know that 65 would be, well, 60 would be, right here would be 60. And 70 would be right here. Okie dokie. Let's go ahead and graph some points here. I'm going to grab the red so we can see it. The x value is 1/4 and 2. Well, 1/4 is super close. Y values are going to go up by 1 also. These will just go by 1. Okay. Now we're going to go 1 and then 3. Well, let's see if that's 5. 1 is pretty close to the x-axis there. Then we're going to have 4 and 4. And then we're going to have 16 and 5. 16 is just past 15. Then we have 64 and 6. Well, here is 6 extended out. Here would be 60. Here would be 70. So we know 64 It's not halfway between them, but somewhere close, right there. So graphing these like this, like this. It opens up and to the right. Alrighty, this last example here, I'm going to let you try to do it on your own. You can hit play and then watch my solution there. We do know that the x, or the vertical asymptote, will be x equals 10, which on this graph here probably isn't really going to work out a whole lot. So we may have to change the graph to, we may have to manipulate that a little bit, make your own. So let's go ahead and pause it. You hit play and check, make sure your table matches mine. All right, so I want to subtract 2 from both sides, so I get y minus 2 is equal to log base 5 of x minus 10. So then I'm going to have 5 to the y minus 2 power is equal to x minus 10. In order to get x by itself, I'm going to add 10 to both sides. And there we go. Find the table of values. You notice in the last example we had that minus 3. Well, we have minus 2 here. So let's start with some values that are somewhere close to 2. Ooh, these numbers might get big. Okie dokie, let's plug in our values. So we're going to have 5 and then 2 minus 2. 5 raised to the 2 minus 2 power, and then we're going to add 10 to that. Okay, 2 minus 2 is 0. So that's 5 to the 0 power, which is 1, and 1 plus 10 is 11. Now we're choosing 3. 3 minus 2. 3 minus 2 is 1. 5 to the first power is 5. So we have 15. And we're going to have 4. 4 minus 2. 4 minus 2 is 2. 5 squared then is 25. And plug a 5 in there. Ooh, 5 minus 2 is 3. 5 cubed is 125. Add 10 to it, 135. And then we plug a 6 in there. 6 minus 2 is 4. 5 to the 4th power. 125 times 5 is 5. 625 plus 10. 635. Okie dokie. You know the vertical asymptote is 10, so it's going to come down really, really close to 10. It opens, well, 5 right here is larger than 1, so it's going to open up and to the right. So if this was your vertical asymptote, x equals 10, I think you can graph it from here. Make your own graph. Okie dokie, there was quite a few examples on there, how to manipulate some things. You would have to know your basic intro to exponential functions, or logarithmic functions, in order how to change it into exponential form. So there you have it. Let me know if you have any questions.